Okay, so check your work, and here's a fun, hard question for us. X cubed plus y cubed equals 5. We're going to need to use implicit differentiation to find the second derivative. And here we go. So implicit differentiation rather than solving for y. Okay, so the first derivative, 3x squared plus, taking the derivative of y cubed, oh that's easy, 3y squared, chain rule, y prime, derivative of a constant is 0. Okay, taking and solving for y prime, I'm going to subtract 3x squared from both sides. I get 3y squared y prime equals negative 3x squared. And then dividing both sides by 3y squared, I'm going to get negative x squared over y squared, because of course the 3's are going to cancel. Okay, so here is y prime. The job, though, is to find the second derivative. Okay, so what's y double prime? Well, the problem with this is I need a quotient rule. And when I use the quotient rule and I take the derivative of y squared, it's going to be an implicit function. Okay, so here we go. So the denominator squared, as in y squared, all squared, and then it's low. D high, the derivative of negative x squared would be negative 2x, less high. D low, the derivative of y squared would be 2y, y prime. And now I've got this awkward situation where y double prime is defined in terms of y prime. So we're going to just simplify this a little bit. I'm going to write this as negative, so y double prime is negative 2xy squared, negative negative, plus 2x squared y prime, all over y to the fourth. Okay, so now what you do is you're going to take and you're going to substitute for y prime and then algebraically simplify that. So what's y double prime? Negative 2xy squared plus 2x squared y times y prime, and y prime is negative x squared over y squared, and the whole thing is over y to the fourth. Okay, so then this simplifies quite easily because this y cancels one of those, and this negative we can put in front and we'd have an x to the fourth. Okay, so this gives me negative 2xy squared subtract 2x to the fourth over y, all divided by y to the fourth. And when you get a fraction in your numerator, we need to clear that. So we're going to multiply the top and the bottom by y. Okay, so let's just take this work up here and finish this off. So I've got y double prime is equal to negative 2xy squared, and multiplying, oh, this y has to distribute to both, negative 2xy cubed minus 2x to the fourth all over y to the fifth. Okay, so just once again, we distributed the y to this first term and got that negative 2xy cubed, distributed it to the second term and the y canceled, and we're left with negative 2x to the fourth, and simplified our denominator, y to the fifth. Now we're going to simplify again. Do you see a common factor? Pull it out. Okay, so let's take out this negative 2 And actually, I guess I've got a negative 2x common to both of them. And I'm left with y cubed minus x, no, negative, pulled out a negative, plus x cubed, all over y to the 5th. Okay, now stop and look back on all of your work and see if there's anything else you can substitute. So, whole problem solving cycle. When you get to the end, you connect back to where you started and you reflect on what you just did. So if you connect that back. I hear a few of you saying 5. 5. Why are you saying 5? Because x cubed plus y cubed is just 5. So negative 2x times 5, which gives you, thanks, I needed that. And what is this? Our second derivative. Way easier than we thought it was going to be.